Good evening, everyone. We are Team Modlux, and our idea is adapter design pattern. Today, we will be discussing adapter design pattern. Our teammates are Oshair Siddiqs, ID 211, Mohammad Siam Bhuya, ID 215, Yad Khoil Shubho, ID 247, Muntasir Hossain, ID 265, Kaji Shakhar Rahman, ID 240, Mohammad Keba, ID 27271, Ibrahima Mahmood, ID 259. The content of our adapter design pattern is definition, real-world example, components, class adapter, components, problem scenario, problem solution, source code, solid adherence, adapter uses. Adapters. The adapter design pattern is a structural design pattern that enables two incompatible interfaces to work together by acting as a bridge between them. It allows objects with different interfaces to collaborate without modifying their existing structures. Instead of forcing changes in either system, the adapter translates one interface onto another that is expected by the client, ensuring seamless communication. The pattern is particularly useful in situations where an existing system needs to integrate with new functionalities but cannot be altered due to constraints such as legacy code dependency, third-party libraries, or architectural limitations. By using an adapter, developers can maintain code reusability, reduce the risk of errors, and the promote scalability while keeping the original implementation intact. The adapter encapsulates the logic needed to convert data, method, calls, and or behaviors, making it an essential tool for achieving flexibility and compatibility in software design. Now we will talk about the real world example. Where imagine a scenario where Vladimir Putin and Xi Jinping are having a high level diplomatic meeting. Putin speaks Russian while Xi speaks Mandarin. Since they do not speak each other's language fluently, direct communication is impossible. However, instead of changing their languages or learning a new one, a translator steps into bridge the gap. The translator listens to the Putin in Russian and translates his word into Mandarin and conveys them to Xi. Likewise, when Xi responds in Mandarin, the translator converts his message into Russian for Putin. The this is exactly how the adapter design pattern works in software development. The two leaders represent system with incompatible interfaces, while the translator acts as an adapter, enabling seamless communication while requiring modifications to their party's language. The pattern is widely used in software integration, while where different systems need to work together despite having different structures. The the adapter design pattern consists of four key components that work together to enable communication between incompatible interfaces without modifying their existing structure. Target interface. This defines as the expected set of methods or functionalities that client system will use. It serves as a standardized structure that ensures uniformly in communication. Any class that needs to interact them with the system must conform to this interface. Client. The client represents the part of the system that interacts with the target interface. It is designed to work with a specific format or structure but remains unaware of the actual adoption while happening behind the scenes. The client simply makes request assuming that it is a communicating with a compatible system. Adapter. The adapter is the core component that bridges the gap between the client and the adaptee. It implements the target interface and the internally makes the necessary conversations to match the format or structure expected by adaptee. This ensures that the client requests are correctly processed without altering the existing system. The adaptee represents the existing system or components that has an incompatible interface. It provides specific functionalities but does not conform to the format required by the client. The adapter works as the intermediary, allowing the adaptee's method to be accepted and utilized in a compatible manner. The adapter class is one of the two ways implement the adapter design pattern. It uses inheritance to adapt one interface to another, allowing compatible a class to work together. The adapter inherits from both target audience and the adaptee. It overrides the target methods and internally calls the adapter methods after converting the request. One of the main advantages of class adapter is that it allows direct access to both the interface and the adaptive functionalities, while since the relies on inheritance, it is limited by the fact that they only adapt a single class, making it less flexible in cases where multiple adaptees need to be adapted. Now let's look at our stock market problem scenario. The app fetches problem stock data in XML format. We want to use a third-party analytical library, but it is only support JSON format. This creates a compatibility issue since XML and JSON have different structures. This is a common real-world problem when integrating different systems, and the adapter pattern provisions provides effective solution. The solution is simple. We use the adapter pattern to convert XML data into JSON before passing it into third-party libraries. The adapter takes XML as an input and processes it and converts into the JSON. This ensures that the analytical library can now work with the stock market app without requiring any modifications to the original functionalities. The methods allows us to integrate new tools while keeping the existing data code base intact. This is our source code. Now let's dive into the most important part, the source code implementation of our stock market app. Step 1, define the target audience. Basically it's a JSON based library, class analytics library. This is the class analytic library, and this is our third party library that we integrate. It only works with the JSON format. Step 2, define the adaptee. We have two classes, class stock market app and the class get data in JSON. And now we need to create the adapter to convert XML to JSON. This is our class adapter. Here is the adapter class. It fetches XML data, extract relevant information and converts it into JSON format using the adapter class in the client code. This is our code. And now we will talk about the adherence to solid principle in adapter pattern. The adapter pattern follows solid principles SPR, OCP, LSP. Adherence to solid principles in adapter pattern. The adapter pattern follows solid principles. SPR, single responsibility principle. The adapter has one job, converts XML to JSON. OCP, open closed principle. We can add new adapters without modifying the original code. LCP, least scope substitution principle. The adapter behaves like a substitute for the expected target interface. ISP, interface segregation principle violation. If the adapter implements too many unnecessary methods, it may become bulky. Dependency inversion principle violation. If the adapter relies on concrete implementation rather than interfaces, it increases coupling. Overall, adapter maintenance flexibility while ensuring modularity. When to use adapter pattern? The adapter pattern is useful while integrating incompatible system integrating incompatible system. The adapter pattern is ideal when two systems with different interfaces need to work together. For instance, if we are working with library that process XML data but your system uses a JSON based architecture, the adapter can convert the XML data into JSON format that your system accepts. This makes integration seamless without altering the core logic of their system. Using legacy code with new features. When upgrading or replacing an old system, like transitioning from a legacy database connection to a new database type, the adapter can act as a bridge. By using the adapter, you can integrate the old system functionality into a modern features without writing rewriting or replacing the legacy code entirely, making it upgrade progress smoother and less costly. Bridging differently bridging different third-party APIs. Many times, third-party services or libraries use different APIs or formats that need to be unified within the project. The adapter pattern can be employed to create common interface for interfacing with the different APIs. For example, if your system uses a payment gateway from different vendors that have unique API formats, the adapter can wrap each one to make them compatible with the internal system expected in interface. Maintaining backward compatibility when a system needs to evolve or update without breaking existing client code. After the adapter can ensure backward compatibility. And now we have the conclusion. To summarize the adapter design pattern helps the bridging incompatible interfaces without modifying existing code, ensuring seamless integration of different components in a system while maintaining flexibility. Thank you. This is our presentation.